Good morning, builders. Hope everyone enjoyed the keynote session. Containers are changing the way that we develop, test, and deploy software, making it faster for us to test and deploy and experiment with these new features and capabilities. But with these newfound superpowers of rapid deployment, come a newfound set of responsibilities. And most of us are turning to container orchestration tools to help us solve those newfound sets of responsibilities. Since about 2014, AWS has been innovating on behalf of you, the builders, to help solve some of these challenges for you. We started introducing ECS in around 2014, or Elastic Container Service. Then in 2017, we introduced EKS, or Elastic Container Service for Kubernetes. 2015, if I recall correctly, we introduced ECR, Elastic Container Registry, which is a Docker-compliant container image registry service. Then again, in 2017, we announced a really exciting new technology called Fargate, which allows you to provision your containerized applications within an ECS cluster without having to worry about managing clusters of EC2 instances and all the heavy lifting that goes along with scheduling, scaling, and managing those instances. And in the fullness of time, we hope to bring that same capability over to EKS as well. Both ECS and EKS take away a lot of the heavy lifting that's associated with typically managing complex cluster orchestration frameworks. And both of those services allow you to bring along your own EC2 instances and run your containerized applications on those EC2 instances. Now, as Adam mentioned, Kubernetes is a very popular service for orchestrating containers at scale. And in 2017, at our reInvent conference, we announced the availability, or introduced, should I say, the Elastic Container Service for Kubernetes. And over the rest of this session, for the next 28 minutes and 15 seconds, what I'm going to share with you is some insights and tips on how to get the most out of Kubernetes when you're trying to deploy it on top of AWS. We'll talk about some of the options that are available to you, and we'll help you try and avoid some of the pitfalls to help get you up and running as quickly as possible and move out of the way so that you can start developing those really awesome and exciting capabilities and features that your customers are asking for. It's always good to start with a level playing field. Can I just have a quick show of hands here? Who has heard of Kubernetes? Okay. Who's using Kubernetes? Okay, cool. Fair enough. Good numbers. So Kubernetes, it's an open source project. It was started at Google in around about 2014 from memory by 3 engineers. A lot of its design principles and primitives were derived from a system that Google used internally called Borg, which they used to manage and orchestrate their workloads across their global infrastructure. It's an open source container orchestration tool that automates the management, the deployment, and the scaling of your containerized applications. And in 2015, if memory serves me correctly, it was the first project that was picked up by the Cloud Native Computing Foundation, or the CNCF. It's since gone on to graduate through the CNCF program, so congratulations to Kubernetes on that milestone. An interesting fact, the CNCF ran a survey a little while ago, and I think close to 60% of Kubernetes deployments actually run on AWS today. That's a massive amount of Kubernetes deployments, and there's a lot of information and feedback that we've been able to gather from customers like yourselves, and I'm hoping I can distill some of that down over the next few slides to give you an idea of how we can better deploy and implement Kubernetes on the platform. So without further ado, let's dive straight into the top tips for deploying. My first tip, and those of you that have deployed a Kubernetes cluster yourself before on AWS, or in fact on any platform, I'm sure this tip resonates with you. But the tip is never try and build a Kubernetes cluster by hand. A quick show of hands, has anyone ever tried to build a Kubernetes cluster the hard way before? Yeah, a few people. Put your hands up if you thought it was easy. Yeah, that's about what we hear from people. It's not an easy process. There's a lot of complexity involved in provisioning Kubernetes clusters on top of AWS, in fact, wherever you deploy them. So there are lots of options available to you. Here is a list of some of the community available options for you. So Kops, or Kubernetes Operations, is a very popular open source project that helps you stand up the base resources that are required through a few command lines, and also lays out an optimized or a best practice configuration for operating a baseline Kubernetes cluster. Tools like KubeADM will, they expect you to have the infrastructure there already, but once you've got the infrastructure, it will then lay out the foundations and the configuration for you to run Kubernetes. A tool that was released recently in conjunction with the general availability of Elastic Container Service for Kubernetes with EKS CTL. This is a tool that streamlines the process for the provisioning of an EKS cluster. If you're looking for more turnkey or enterprise-grade solutions, EKS is obviously a very popular option that we're seeing customers turn to now, but there are options by organizations like Red Hat and their OpenShift product as well. Some of our partners like Heptio have released quick start guides that help you get started deploying Kubernetes on top of the platform very quickly with pre-canned CloudFormation templates and step-by-step guides. So I would encourage you to hop along and look at some of those. And then we've got some of these other options that I've listed down the bottom here. So things like CloudFormation and Terraform. Terraform, very popular with our customers, and again, in conjunction with the availability of EKS, some very thoughtful individuals put together an EKS module for Terraform as well, so you can now provision EKS clusters using Terraform. And then we've got the standard configuration management tools like Ansible and Puppet, which we can use to manage the configuration of our clusters once we've deployed them. Kops is a very popular option, as I mentioned before, and in fact, we have an open source workshop. If you pop along to AWS Samples, the GitHub organization or the project, you'll see the workshop there, and it guides you through provisioning a cluster using the Kops tool. It's open source. It's driven by the special interest group for AWS within the Kubernetes community. There's regular office hours, and if you'd like to learn more about that, I'd encourage you to pop along there and have a listen. One of the really nice features of the Kops project is it can output CloudFormation templates and Terraform manifest files as well, which you can then use to drive the deployment of your own clusters or use as a baseline foundation to start customizing and configuring your own Kubernetes clusters. Here are some of the options that are typically available when we deploy a cluster using Kops. You can see there we're specifying some availability zones. We're choosing a master count, so this is the control plane that's responsible for scheduling of our tasks or our pods across the cluster. We're choosing an instance size, and we're specifying the nodes, and the nodes are where the action actually happens. This is where our containerized applications will get scheduled. There's a few more variables in there, but essentially when we run this command, that gets written to a configuration stored in S3, and then our cluster, we can then deploy our cluster using that configuration. Very quick, very easy, and a really good way to get started with Kubernetes quickly. Once we've deployed the cluster, though, there is a lot of operational work that goes into managing and maintaining that cluster. We've got things like security of the cluster. We've got managing the reliability, making sure that our nodes and our masters are highly available. We've got to make sure that we're backing up the persistent data store that stores the state of our API. All of this heavy lifting that goes into managing the cluster really gets in the way of what we're here to do, which is focus on building cool applications for our customers. So we listened to that feedback and we introduced EKS, or developed EKS, Elastic Container Service for Kubernetes, which went GA in around June time. Currently available in US East 1 and US West 2 regions. What is EKS? Well, it's this. It's a multi-availability zone deployed Kubernetes control plane. So we typically deploy, or we always deploy, 3 master nodes for you. This is where the cluster itself is managed and operated from. We provision for you a highly available distributed data store in etcd across 3 availability zones, again, to give you that peace of mind that we're anticipating failure, we're thinking operational best practices. And then we give you the ability then, as I mentioned previously, to bring your own EC2 instances to the party and run your containerized applications on those EC2 instances. Once we've provisioned that cluster for you using a simple command line tool or using the user interface, you end up with an endpoint. And we take the endpoint, we feed that into our kubectl utility, and through the magic of APIs, we're able to start provisioning containerized workloads into our Kubernetes cluster. So when we're thinking about deploying these clusters, remember, there are options out there that are much easier in doing it the hard way. Use the community tools like Kops. Always think about provisioning this infrastructure as code, and Kops goes a long way to helping us do that. CloudFormation templates and Terraform are also really good options to help you get moving with this infrastructure as code pattern. And EKS is a really great option to get started with running Kubernetes on AWS, and currently available in US East 1 and US West 2. My next tip is around networking options. Now, networking is at the core of most, or if not all, distributed systems, and Kubernetes is no different, and the applications that you deploy on Kubernetes are no different. We really have to spend some time thinking about this and understanding the requirements of our application. Kubernetes has a very simple principle around networking. Every pod needs to have its own IP address, and all of those pods in the cluster should be able to talk to one another. How do we go about implementing this IP per pod model? A few options. Kubernetes supports the CNI framework, which is an open standard for essentially wiring your containers into an underlying software-defined network, container networking interface. It's a pluggable architecture, which means that there are lots of third parties out there developing these CNI plugins that we can bring into Kubernetes. Each of them offers a variety of different capabilities. It's also a CNCF project, so its development is closely aligned with that of the Kubernetes project as well, which is great. Here's an example of some of the options that are available to you with regards to CNI plugins. Flannel is a very popular one. Weave also has a very popular plugin there. We've been developing our own, and I'll talk a little bit more about that shortly as well. Lots of options. How do you go about choosing those? Well, again, back to my original statement, understand your requirements. Each of these plugins requires a very specific environment to operate in. Some require a data store to store the configuration. Some require an overlay network. Some offer advanced capabilities like the ability to segment traffic between the applications that you're deploying within the cluster. So understand what you're looking for before you make those decisions. Another option, especially when we're deploying clusters using the Kops tool, is Kubernetes. Kubernetes is a very simple implementation of a networking provider that enables us to network our containers or our pods within the cluster. Now, the way Kubernetes works is it takes a CIDR block and it allocates a CIDR block to each of the nodes that we deploy within the cluster. Then when we provision a pod, each pod gets an IP address from that CIDR block that we've allocated. Kubernetes then registers the CIDR block that's attached to that EC2 instance within the VPC route table. That's how the routing happens between the various pods within the various nodes across the cluster. Those of you that are familiar with VPC networking and some of the constraints of that, you will straight away realize that there's a limit there around 50 routes per VPC route table. This might be a reason for you not to choose to use Kubernetes, especially if you're thinking of scaling your cluster beyond 50 nodes. So what other options are there? Overlay networks, and I mentioned overlay networks briefly earlier on. Why might I choose to deploy an overlay network? Well, it could be for the obvious reason I just mentioned. Perhaps I need more nodes than the Kubernetes provider supports or offers. Perhaps I've architected my VPC and my subnets with my original design, which related to hundreds of EC2 instances, which is very different to thousands of containers, each of which need their own IP address. So it might be simply I just don't have enough IPs. Or it might be that I want additional capabilities over and above what the standard networking providers can offer me. So things like network policies I've called out specifically there. I'll talk more about that shortly. One simple implementation of a networking provider that supports overlay networking is Flannel. So Flannel can be deployed again using Kops through a few configuration options. And the way this works is very simple. It has a bridge adapter and a daemon that sits on each of the nodes. Essentially, all of the packets that need to traverse the network get encapsulated with a few bits of information about the destination and the source of those packets that need to traverse the network. And then the packets are sent out through the elastic network interface of the host, encapsulated, passed on to the destination node, de-encapsulated at the other side, and forwarded onto the appropriate pod. This is great. It's very simple. It's very performant. However, it does come with some challenges. I mentioned encapsulation. And encapsulation incurs some performance penalties. There's lots of CPU cycles associated with encapsulating and de-encapsulating packets. So this is something to be mindful of. Do you need an overlay network? Not necessarily. I mentioned we've been developing our own capability in an own CNI plugin, and this is the CNI plugin, the Amazon VPC CNI plugin that we've developed in conjunction with the launch of EKS. The way this works is we actually assign the pods within the Kubernetes cluster their own IP address, which is native to the VPC itself. So essentially, each of the pods within your cluster act and behave very similarly to that of an EC2 instance. So you can see here when I start up my cluster, I have a CNI plugin. It reaches out to the VPC. It gets an IP address or a set of secondary IP addresses and allocates those to the elastic network interface of the node. When a pod is started, so my Java pod here, it starts up, it requests an IP address, and we allocate an IP address, one of those secondary addresses that's attached to the primary interface, to that pod. All of a sudden, then, that pod is able to route natively across the VPC using the standard VPC routing fabric. This is a really performant option. There's no encapsulation and decapsulation. And using tools like VPC flow logs, we can gain much more visibility into the traffic as it starts to traverse our cluster. That's available online now. It's an open source project. It's out of alpha, I think now. It's general or a stable release, so I would encourage you to hop along and have a look at this. It also isn't restricted to working with EKS, so you can actually use this plugin with your own deployments of Kubernetes using things like Kops. So with regards to networking, all of our pods need their own IP addresses to communicate with one another. As I mentioned before, Kops, the tool for deploying clusters, defaults to using the KubeNet provider. It has some limitations, so just be mindful of the potential scale of your cluster. CNI is a great option. There are plenty of plugins that are available from various providers out there to facilitate communication between your pods. And Amazon EKS currently supports the Amazon VPC CNI plugin, but you can also use that with your own Kubernetes deployments on top of AWS. With regards to networking again, I mentioned briefly network policies earlier on. Those of you that are, again, familiar with VPC will have identified a slight challenge with the design model I talked about earlier, and that is that if all pods are communicating over a single ENI and a security group is as a resource that's attached or a property of an ENI, how can I restrict the flow of traffic to specific pods within that instance? We address that through the use of network policies, which are a native Kubernetes API object. And the AWS VPC CNI plugin supports the Calico network policy engine. So what we can do with the Calico network policy engine in conjunction with the VPC CNI plugin is we can create model policies that reflect the application calls that we need to make across our distributed system. So we see here we've got 3 pods deployed. These can be on the same host. They can be distributed across different hosts. We're going to apply a basic policy that first of all denies all access between those pods, all traffic between those pods. The next policy we're going to provide, we're going to attach allows inbound access from the outside world. So you can see the 000 side of block there. And we're attaching that policy through a label to the front end. Once we attach that policy, traffic's now able to flow inside. We're now going to attach another policy, and these policies are additive, and this policy is going to be attached to the cats container, and the cats pod. And this cats pod now is able to accept requests over port 80 from the front end. And we'll keep building and building and building, and we can model these network policies in exactly the way that we want our application flow to look, keeping in mind the principles of least privilege and least access. Isolation, it's network segmentation. Isolation itself, how do I isolate the resources within my cluster? We have a solution to that. Kubernetes has a concept called namespaces. Namespaces allow us to isolate resources within our Kubernetes cluster. When I talk about resources, I mean basically everything you can create and consume within a Kubernetes cluster. Services, pods, memory, CPU, all of those resources can be isolated and segmented into these namespaces. So simply here, what I've done is I've created 2 namespaces. I've got a dev and a prod, and this might be the pattern that you decide to adopt. By creating these namespaces and then allocating policies to these namespaces, I'm restricting who can access and interact, both from an API perspective, but also from a network perspective. So I can fine-grained control over the network traffic flow, the east-west traffic flow between the services that I deploy within my cluster here. Again, simply by defining the namespace itself. This is segmentation. Network policies is a great option for that. Isolating the resources within your environment using namespaces, and those namespaces can follow teams, departments, release cycles, however you want to do them, it doesn't really matter. It's entirely up to you. And resource quotas is another great option that's available within Kubernetes to allow you to have much more control over which services, which applications, which containerized resources consume what resources. And namespaces themselves, again, I already talked about that. Another element of isolation that I haven't talked about yet, and I think it's really important, and that's why I've given it its own tip number, is RBAC, or role-based access control. AWS offers role-based access control through IAM, or Identity and Access Management. Kubernetes has a very similar model for implementing role-based access control. We're always going to try and implement least privilege. That's the well-architected way. With the launch of EKS, actually prior to the launch of EKS, Heptio, another, again, a partner I mentioned earlier on, released a really great integration called the Heptio AWS Authenticator for IAM. What this allows us to do is allows us to use AWS credentials, which we're already using to control access to resources within our AWS environments, to control access to resources that are deployed within our Kubernetes clusters. So by installing the Heptio Authenticator onto our workstations, we're now authenticating against the Kubernetes cluster with a token that's provided by the AWS Authentication Service, at which point then we're handing off the role-based access control of what we're able to do within the cluster back down to the Kubernetes role-based access control tables themselves. This means that we've got another one less area that we have to worry about. Can you imagine having to manage sets of identities both in Kubernetes and their role-based access control world and IAM as well? Again, heavy lifting that probably is not a great use of your time. When we think about creating policies for role-based access control, we can map these policies to roles within IAM, and it might be that we want to restrict developers, operations engineers, to perform specific actions within specific namespaces, and using what we call a role binding and a role, we can do that. So I can restrict both users and service accounts, and these are credentials that we allocate to a specific application that could be running in our cluster. I can restrict them down to these very specific functions only within a namespace. And then using what we call a cluster role binding, I can do the same thing, but at a cluster level. So now my service accounts and my users are able to list and get pods across the entire cluster. Remembering that least privilege access is extremely important, and we should follow that model irrespective of whether this is just Kubernetes or just AWS or a combination of the two. And role-based access control helps us do that. Don't give kube control, the utility, to everybody. Everybody doesn't need it. There are plenty of ways to interact with the Kubernetes cluster without using kube control. So consider your access patterns and who actually need access to the cluster. And we've got these great tools by third parties. Again, Heptio keeps coming up because they're such an awesome partner in this space. They've got tools like Sonobuoy that help us assess the security posture of your Kubernetes clusters, and you can run these tools against them and get some interesting reports back. Next tip, monitoring all of the things. This is extremely important. Kubernetes is a very dynamic environment. Containers are very dynamic resources. They come and go extremely quickly. And there's lots of telemetry that gets emitted from these applications that we deploy. Here's some examples. We've got clusters and nodes and containers and applications, and each of those is emitting some kind of information that we need to capture to be able to assess and analyze and make decisions about the right path forward for our applications, diagnosing and debugging problems in our systems. So having tools in place to capture this information that adapts to the dynamic nature of our solutions is extremely important. One pattern that we see customers adopting a lot is the F stack, the Elasticsearch, FluentD, and Kibana stack. In this pattern, what we do is we deploy FluentD as a daemon set across the Kubernetes cluster. That then listens and captures log information that gets emitted from the pods within the cluster. We then ship that information over to CloudWatch Logs, which is subscribed to an Elasticsearch service. That information gets fed into an index, and then we're able to visualize that information using Kibana and make some interesting decisions and gain some insights about how our application is performing and behaving on the cluster. If we look at this graphic here, what you can see, it's really trying to articulate the various levels at which we need to be thinking about the metrics and the telemetry coming from our cluster. So if we look at the purple layer there, we've got data coming out of our nodes and our applications and our containers themselves. We then need tools to aggregate that information, and I already talked about things like Elasticsearch and Kibana to visualize that. Prometheus is a very good option, a very popular option. We also then need to drive insights and actions from those statistics or metrics that we're getting from the cluster itself. So using Alert Manager, which is part of Prometheus, and many other tools out there. And then the visualization piece, which I talked about earlier again, that helps us understand what's going on, put dashboards around our offices, see pretty pictures, because that always keeps the management happy. And then underlying all of that, we need a data model that supports the kinds of data that we're going to be emitting from our cluster. Prometheus is a time series system, so all that information needs to get stored in things like InfluxDB. Lots of options, some great partner solutions out there that can help address this without having to do it all yourself. So I would encourage you, I think New Relic are out there today, so go and have a chat with those guys and see what they can do for you in this space to try and solve the problem of monitoring all the things within your cluster. The tools that you have to monitor need to cater for the dynamic nature of the environment. That's not just the containers that are continually shifting and changing shape and mutating, but it's also the EC2 instances coming and going on a fairly regular basis, especially if you're doing lots of auto-scaling. The log information from our applications and our clusters are going to give us the insights that we need to make logical decisions about the way forward for our applications. We continually need to refine these operational procedures, and the only way we can do that is by capturing that information and gaining insights from it. And I already mentioned some of the partners out there. New Relic is out there now. Datadog has some great solutions to help solve that problem as well. Tip number 6 relates to the building, the shipping, and the running of software, which is really what Kubernetes is all about. It's about accelerating our the deployment and the closing and reducing that feedback loop with regards to the software and experiments that we're performing. How do I do rapid software deployment and testing and gain lots of insights very quickly? Well, there's lots of tools available to help you solve this problem right now. Jenkins, there's the whole suite of code services there that I talked about. Lots of interesting open source projects coming up in this space. Spinnaker's been around for a while. It's part of Netflix suite of open source software. Scaffold is a really interesting project that really kind of bridges the gap between local development and Kubernetes-based development as well. Tools like Brigade, Draft is another exciting project in that space as well, and I would encourage you to pop along and have a look at some of those. And then we've got partner solutions by people like GitLab and Shippable and Circle CI. I wanted to take a quick second just to quickly go through a solution that was put together by one of my colleagues, a gentleman called Omar Laurie. This is a reference architecture that you'll find on our public blog. And it talks about how we implement a continuous delivery pipeline to Kubernetes using the code suite of services. So here we're using code pipeline to orchestrate the flow. Our developer is checking in his code into code commits. That's then triggering a workflow which involves taking that code from the source code repository and building a container image. So code build facilitates the building of that container image for us. Once we've built that container image, then we're going to ship that container image. This is our deployable artifact. We're going to version and tag it accordingly. It's going to be dropped into ECR, Elastic Container Registry Service, again, which I mentioned before, was our Docker-compliant managed container registry. From there, then, the next step in the process is to fire off a Lambda function. Now, what does the Lambda function have to do with this? Well, currently, right now, there is no native integration between the code suite of services and and Kubernetes. So Lambda provides that glue, as Lambda tends to do so often. So what we're doing with Lambda here is we're taking Lambda and we're retrieving some attributes about the application that's already deployed, and we're rewriting the Kubernetes API object that represents the state of that application or that deployment at the minute with some new information that relates to the image that we've actually just created and pushed into ECR. Once we've rewritten that information, we then deploy that information back into the cluster using the API calls, and Kubernetes will then do a rolling update of our application across the cluster by pulling the image from Elastic Container Registry. Fully managed, mostly serverless with the exception of the Kubernetes piece. And again, it's a blog post that you can pop along to and have a look on the public blog. A lot of the tips and the summaries in this section are fairly common sense to most people, but deploying small and frequently gives us the flexibility and the confidence that we can quickly roll back in the event of some kind of issue. Kubernetes supports this concept of rollout histories as well. So when we're creating our deployments, some of the attributes that we can define within the manifest files allow us to specify a retention period for previous versions of our API object or our configuration, which gives us a quick way to roll back to that previous state. And the containers themselves support this concept of a liveness and readiness probe, which means that we can perform checks on the application when we've deployed it, just to be sure that it's doing what we want it to do, rather than releasing it to the outside world before it's ready. You might, for example, be running an internal bootstrap process when the container comes up that maybe does a git pull from a repository, for example. You don't necessarily want that container to start serving requests before it has completed its bootstrap process. So in summary of all of the exciting things that we've talked about, there's lots of options available to deploy these clusters on AWS. Kops is a very popular open source project. EKS is now available in US East 1 and US West 2. With regards to networking, make sure you fully understand what your current architecture looks like, potentially what some of the constraints are, and what the requirements are as well for your clusters going forward. Thinking least privilege, segmentation, well architected. Make sure that you use the capabilities of the platform like namespaces and role-based access control to drive those best practice cluster configurations. And always make sure that we have the appropriate tooling in place ahead of time to capture the log, application information, the tracing information, so that we can make some intelligent decisions about how we evolve our application architectures going forward, but also to help the operations guys that are managing these things at 3 a.m. in the morning when the pager goes off. This session has been primarily focused on the deploy. And that's the problem space that Kubernetes primarily addresses, the deploying of our applications. After this, I'm going to be doing another session which focuses on the runtime of containerized applications. And I'm going to talk about a technology called Service Mesh. If you're interested in learning more about Service Mesh and seeing how we might deploy a Service Mesh onto Amazon EKS, stick around. It would be great to share some insights with you. Thank you very much for your time. We really appreciate it. Make sure you fill out the feedback forms. Obviously, we're always looking to try and improve on these sessions and get your feedback, so that's very helpful. There are some takeaways that you can go and grab from the people outside when you scan your badges, some content links that we'll share with you. And with that, I will let you go and have a break. Thank you very much.